Hi, good evening, everybody, and welcome once more to a very exciting, interactive learning session, a Tinker from Home, Learn Yourself module, which is going to be broadcast both on YouTube as well as on Facebook. And it is on a subject that is very dear to most of the students who are operating in adult tinkering labs, and of course, any student or teacher or participant who is going to be attending this particular call. As all of you are aware, and I hope every one of you is safe and sound even during these very difficult COVID-19 times, and every one of you is practicing the necessary safeguards advocated by your school, your state, the ministries, or by the government in order for us to all be safe. Now, as all of you are aware, Atal Innovation Mission has been very active during this lockdown period, thanks to a very energetic team of Atal Innovation Mission who have been keeping you busy and engaged through a number of interventions, which include Tinker from Home modules that we have launched over the last couple of months. We launched 4 modules, which were very, very warmly received by all the recipients, all the students, including the teachers and the mentors. And these were on artificial intelligence, which is making a lot of changes in the world. Second one was on 3D design that we launched along with NIC for how do you do design on 3D printers. And another one was game development along with Dell Technologies and Learning Links Foundation, where you learned how to transition from a game player to a game maker. Now, all of these are very, very interesting modules, and many of you, thousands of you, have responded beautifully. You'll have logged on to all the website, the YouTube sessions. We have seen the number of hits go up every day from all of you. And of course, the Atal Community Day Innovation, which was leveraging all of these technologies. You responded greatly to that. More than 1,100 innovations entries have been submitted by all of you, and that too during a lockdown period. So it is amazing that you have found the time, the inclination, the energy for doing all of this, and that is what Atal Innovation Mission is all about. The Atal Tinkering Labs is one of the biggest game-changing initiatives in India at the school level, so that we are including and we are infusing in you a problem-solving, innovative mindset through tinkering in with latest technologies, 3D printing, robotics, IoT devices, miniaturized electronics, augmented virtual reality, do-it-yourself kits. And with these do-it-yourself kits, you are able to allow your imagination fly high. You are able to create innovations using your imagination, looking at the problems that are in and around your community, and you solve these problems leveraging technology. And it has been wonderful to see not only students from the metro cities, but from the tier 2, tier 3 cities. We have adult tinkering labs in more than 700 districts. And it is amazing to see the entries come from all over the country. So now, today, we have a wonderful special guest who is already a mentor of change from the mentor community of Atal Innovation Mission. He is Dr. Guruprasad Rao. He is a fellow IIT Bombay alumni. He has 30 years plus experience in the industry and academia, and he is the director of Imaginarium India. What a wonderful name, Imaginarium, allowing your imagination to express itself just like an aquarium. Your imagination comes alive in an Imaginarium. And this is one of the leading 3D printing organizations of India. Dr. Guruprasad Rao is the director and mentor leadership team at Imaginarium India Private Limited. Now, his current focus, and he has many interests, but his current focus is on skill development, 3D printing, medical applications, DFAM for metal 3D printing, besides technology mentoring and technology partnerships across domains. Dr. Rao is a technocrat with over 30 years of experience encompassing industry and academia. He holds a BE Mechanical with post-graduation in tool engineering from GTTC. He has an MDes in product design from Indian Institute of Science, Bangalore, and a PhD from IIT Bombay. For his terminal degree, he worked on medical applications of 3D printing. He's also currently pursuing medical law at NLSIU. So he's a man who is still learning, and that is incredible considering his experience, his proven technical knowledge, but his thirst for learning has not decreased. He has bagged many awards, including 3 gold medallions. As an accomplished industrial designer, he holds 8 patents and 100 plus design registrations. His research interests include product design, product aesthetics, design management, 3D printing, and its applications in the medical domain. So, dear students, teachers, and principals, as well as mentors who have logged onto this call, we are going to have a wonderful interactive session on the world of 3D printing and 3D design. And no better person to speak to us than Dr. Guruprasad Kupparao. I would like Dr. Rao to introduce himself, say a little bit about what led him on this 3D printing journey, what triggered his interest in this, and a little bit about his organization and how it is helping would-be 3D innovators across the country to better themselves in this exciting new technology. So, Dr. Kupparao, it is up to you.
Thank you, Mr. Ramanan, for a very generous introduction. Very good evening to all the students, principals, and my fellow mentor of change looking at this program. I think 3D printing was, very early. We could get introduced to it during my PG, post-graduation. I did it in 1992. Then that's where we heard about 3D printing. And there was a small short notes to be written. That's the introduction to 3D printing we had. Very few lines were there. But in 93, when I was with Titan, somebody brought a 3D printed object and they told me, so this is a ring. It was looking like a crystal. And I could not believe it. It's made by a machine. And much later, when I joined, I took a sabbatical leave from Titan, went to IISc Bangalore for doing my post-graduation in product design. The department head, was receiving, he called me and said, "You're from industry. I'm going to give you a special task." What is the task? There is a new equipment coming to the lab today. You have to manage it. So he gave me a key, a room, and I was waiting patiently for the arrival of the box. So somebody delivered a box. So and along with the engineer. So what we unpacked was actually a 3D printer, and it's called Prodigy. The name itself was very nice, and it was a small little fellow, highly capable of doing anything. Very intricate, and it is mission, and it was 2000 December sometime. Till then, I had no idea about 3D printer. In 2000 onwards, till 2003, I was actually running one guy who used to clean the mission, load the mission, maintain the mission, all, it used to run almost 24/7. And we used to have a branch of TCS in IISc campus called APDAP. And I used to really cater to them. Besides giving training to students, I was also a student and making all our projects on great insight into what can be done, how to orient a product, how to slice it, why we have slicing it, and all that, intricacies of 3D printing I learned. And much later, after I left the campus, I came to join Crompton Reeves. I was heading their global R&D from industrial design, and there we used a lot of projects. In fact, first of them was about centrifugal gear. When centrifugal gear was being worked for over 6 years there, somehow they could not crack, how to make it perfectly. So because I knew 3D printing, I immediately could contact IIT Bombay, where I met Professor Boppert, and he connected me to Protosis. And that's how the part which was waiting for last 6 years, 3D printing, was able to be done. And much later, when I joined IIT Bombay, where I met Professor Boppert, and he connected me to Protosis, and that's how the part which was waiting for last 6 years, 3D printing, was able to be done. And that's how got fine-tuned, and we could actually successfully test it. So having an idea and how to successfully test it is best done by 3D printers. You know, Hand making, of course, as a product designer, I've always been carving things. As industrial designers are little bit of artists and engineers rolled into one, and we used to make things, by POP, by clay, cardboard, you know, Toad, Ford, or Jode. Was always there, part of our life, and I think that's how I got introduced to 3D printing. Much later, when I again joined Imaginarium as the CEO in 2011, that's when I was introduced to the world of 3D printing. Like SLA, SLS, then multi-jet fusion, then multi-jet modeling, MJ, which are using resins and wax, for example. And in fact, when I was working in Tanish, we had used lot of investment casting. Now I am seeing the same thing in Imaginarium also. We have a vertical called Imaginarium Precious, which works on jewelry. And in fact, the early founders of Imaginarium were trying to give these wax or resin models to the manufacturers freely in order to try. You try and tell me how it is going to work. So they created a market whereas there was none. And incidentally, there was a lot of a context, just like a COVID. No, there was a period when a different kind of renaissance was happening. The Babus who are making the artifacts were really very egoistic, and handling them was difficult, and they were taking long time to translate a sketch to a artifact. And somewhere the CAD was coming, there technology came, you know then industry had an option where they can adopt, a better option, a nicer option, and in fact a best option, as 3D printing. And slowly, we would even today our Imaginarium Precious is a largest vertical we have, and many people think that we use for jewelry. Something taught us, jewelry, the intricacies, the finish, the finesse, what you need to have in anything, whether it is engineering product, medical product, or an artifact, we know exactly, because we don't see finish by blindly touching it, but under microscope. They use the loops in order to know where is the microstructure, how is the microstructure. If there is a blowhole, how to handle it, how to take care of it in the next casting. So today we are sitting on a large group of people, highly skilled, engineers, artisans, who can create simply anything. And so we say we convert ideas into reality. So Imaginarium started, taking up every type of order. So people, they will give. So we'll say, okay, we'll let us try. Why not? Why not? And so this led to adding a lot of verticals. Today we serve more than 5,000 customers, and we have different verticals, and we go into aerospace, automotive, FMCG packaging, heavy engineering, precision engineering, medical devices, medical, surgical guides, implants, and you have, of course, jewelry. I've already told, objects for Bollywood and Hollywood also.
So that's wonderful,
Yeah.
Dr. Rao. And I was just, we have all young students now who are having their first introduction and their first view of a 3D printer, right? And they are very keen to start innovating. And you have outlined so many areas in which 3D printing can be useful, from jewelry to medical applications to the manufacturing technologies, to masks, for example, now which are being, preventive equipment for COVID-19, the PPE equipment, which is all being designed and manufactured with 3D technology. What do you think? I mean, so let's look at it from a student point of view. A young student, an aspiring student, wants to become one of the finest 3D printing designers and manufacturers of some particular dream object of his or product of his. How should he go about learning and becoming better and better in leveraging 3D printing and using his imagination to create solutions? What would be your suggestions to a young student who starts on a 3D printing journey, innovation journey?
Very interesting question. I think uh, I will start with one small this thing. If you don't mind it, it doesn't matter. In order to make something matter, matter, you have to mind it. That
Yeah,
means we need to identify needs actually. You know, so I was typically telling students, we'll give you a challenge. You give me 365 ideas. What you are going to do for a year on a 3D printer? I will give you a 3D printer free. You know, a challenge. But there was no takers. So writing down ideas is very difficult. So if you have a 3D printer, it is very important to know what I'm going to print. Am I going to print every day one nut because I'm able to make a nut, or I'll make a sphere, I can keep on doing a sphere? No. So it is very important that when they know, before that they need to know what I'm going to do with the 3D printer. 3D printer is like a robot. you know it is at your command. It is like your Aladdin's this thing. You make it, but you need to give it a 3D file, otherwise it will not print anything. So I will suggest that they need to understand what is known as design thinking. you know so our world around us has lot of imperfections. you know for example, a door is there in the class. It bangs with a for wind, and it disturbs you. So you want to do a small stopper for that. you know so that is a need. There is no stopper. So I will say that you have to identify something like that. In surroundings, what are things which are needed. For example, there is a tap in the kitchen, and water gushes down and loses a lot of, it doesn't fill the mug, but everything goes out because of the pressure. So you need to make a small impeding shower cap or something, which will make the water to come at a reasonable speed, so that you can fill the mug. So that is not available readily in the market. So now this need, they need to translate that into a drawing, and the drawing they take it into CAD. There is a Tinker, whatever you have, a lot of open source CAD softwares available.
3D design tool we have given them.
So 3D design is very important. Then you can play anything. So a 3D printer like this one, what you see, makes a lot of artifacts. Looks so nice, but it can do nothing without a CAD. 3D CAD. So 3D CAD is very important. And one, luckily, the boys and girls have an option. They can download from the internet lot of primitives available. You know, they can pick and place them together, fuse them, and make a new artifact. But if they want to do something which is very intricate, like this one, a cartoon character, in all its color, one has to actually learn how to make this. You know,
So I think your focus is the camera focus is slightly hazy. Um, could
oh,
you
okay.
could you adjust it?
Can you see this?
Yeah, yeah, you can see.
You can see, it's a completed model.
Yeah,
And such model, if they want to build, they need to have the skill in the CAD. you
right.
know so I think it is going to come with interest. But what I'm saying is, they can make a toy. For example, they've got a toy is broken. you know how to put the broken part. You design that part and add it, or you can toad ford or jod. Can you break a toy and make it into a new toy, you know
Yeah,
by having some kind of a synthesis. That is also possible. And so it is all about finding a need where you want to apply. And I think starting with simple ones, that gives you confidence. They can start with a very small thing. And for example, a cylinder like this, what you see here, it's all
right,
made up of cardboard.
right.
When the cylinder is designed, actually it is made by in a 3D printer in a different way. It is sliced. These slices, what you have. So it is like what you have in the nursery, that toy where you keep on stacking.
Right.
So like this, in a 3D printer, every layer gets added one by one, and so it's additive manufacturing, they call it.
Uh,
So you can see here how I'm placing the things by hand. That is done by the computer
uh,
program, and it is something like this. The digital model is sliced, keep it back, in order to get the full volume. So it
oh,
could be the same case with anything, even a complex thing like what you have here, a lattice structure, what you have of
yeah.
a car, you know, and the entire thing, it is also sliced and given to the 3D printer one at a time, so in order to make this, and you have artifact like this, for example, it is a murti, it is a uh, sculpture. This is a
Right.
Professor Sharma, who headed Udicity in Bombay, you know,
Oh, okay.
and this was sculpted by my colleague, and this was 3D printed, you know, and you can see the detail of this, very, very accurate,
Right.
like in likeness to his this thing, and
So
this is
what
done.
went into what went into making this such an accurate replica of his face and his structure, body structure? What went into
Well,
that?
one is the photography we do.
Yeah.
We take photographs from different angles.
Right.
Then it is taken in CAD, and there is a software called ZBrush. It's called digital sculpting.
Uh,
So you can digitally sculpt. So on the screen, what you get is a some kind of a sphere.
hmm.
It is like clay. You push and pull the
Hmm.
vectors on the clay to transform it,
Okay.
into the object, and this started as a sphere, you know
Oh,
and
okay.
ended as a sculpture,
Yeah.
so you can very skillfully pull and push things, and there are interfaces like that, where you have a pen like thing, which will, if you press hard, it is going to give you a hard this thing. You
Ah,
press lightly, it will give a light shade. The same
yeah.
thing happens with the CAD,
Okay.
So you're able to play just like how you play with the CAD, the clay. you know.
Right.
So I
Excellent.
think it is very
So
important.
yeah.
Students can start with plasticine also. You know, on one side plasticine, the other side you have a CAD.
Yeah.
See what happens with both the things. So there is an
Okay.
analogy, direct analogy.
Yeah. Excellent. I think the three very important points that you brought out. One, you should start with an idea, and you said that the idea part is so important. What is it that I want to do, and why do I want to do it? You know, because it should solve a particular problem. Like you mentioned, the tap, the water gushes, so you want a device which can regulate the flow of the water. So you want to create that device, and then you have to give accurate dimensions and all of that stuff. So you look at a problem, and then you say, hey, I have an idea now which I can use for my 3D printing. And then you have to design it. The next element is the design part. And the design part is very important because unless you design the solution, you will not be able to realize that particular product that you have in your mind. And for design, you have several tools. And so you should become familiar with how to use those tools. There are 3D design tools, CAD tools, computer aided design tools. And these tools are very important for you to be able to come out with the nitty gritties of that particular product. And then you talked about additive manufacturing or additive technology, where 3D printers enable you to create a particular structure and then repeatedly create and assemble it in a manner that finally yields a large product. And you gave 2 3 very good examples of that. And finally, even when you go to like sculptures and things like that, there are many other tools which help you in designing the face, the creases. For example, when I was looking at that sculpture, so very accurately they have shown the cheekbones and the hair behind and all of that stuff, and that requires you to start learning about new tools. There are camera sensing tools, and then there is a editing tool, using maybe various other tools from different manufacturers like Adobe and so on and so forth. So there is tremendous excitement in the creation of an end product using 3D printing, but starting off with your idea and your imagination and then converting it into a real-time product. So it's wonderful. Can Dr. Rao, you're also a mentor of change for not only Atal Innovation Mission, but also for many other people. What has been, how important is the role of the mentor? We have a lot of mentors in Atal Tinkering Labs. Now, some of them may not be familiar with 3D printing and 3D technology. Some of them may be management graduates and so on. So, as a mentor of change, what would you suggest that other mentors should learn or should contribute in the world of 3D printing, and how can they do that?
Interesting question, Manan sir. It is like, really, yes, true. And I think they are only acting as a motivators, facilitators, and they can also learn along with the children. So one key thing in the whole innovation Atal mission, what I've seen is the energy with which people have only one thing, that is to learn, and learn, and you bring that out, the learning in the form of a solution, and in that respect, I think uh, mentors of change can invite people who know about various things, like for example, you have AR VR now. A lot of people in the IT enabled experiences that are going to come in future, the mixed reality and all. So such people can be called to share with children. People who know 3D printing, they can come and demonstrate, or a artisan who wants to make a pot, for example, from a wheel. They will learn. It is not about only one technology, but I think it is the way people learn to use and know the options available, and how India is rich with its the craft system also. The people who make, for example, a basket using bamboo, for example, a flower fellow who will make the flower garland. What is the dexterity with which they have this? The weavers who make such a nice clothes, with even with a charak, for example, how they take out the khadi, one thread, for example, from the cotton. All this, I think it is very important to bring such people, resource people from all over the country, invite them, and give a I think if you go to northeast, you have a lot of bamboo related things will be there. If you come to south, stone sculpting, terracotta, and all such things are there. And if you go to Chennapatna, for example, there is Chennapatna toys. The people, they carve out anything in their own local made lathe. You cannot even call it as lathe because it doesn't use electricity also. There is no check and all. He puts in leg and do it. And such things, when they are brought and demonstrated to students, they they think that, okay, world is, after all, it's fun. Learning is fun. And I think that's where the mentors of change would be happy to bring and foster innovation. Because I think the Indian government has made such a great mission, and you at the helm of it, driving this entire ship, the innovation ship, as a captain. I think all of us, mentor of change, should bring this about, make this happen in every small clusters. you know I think that's the message what I have. We should co-create. Let us join hands, get the best people, let them go to south, east, north, south, share resources. And I think that's where, every mentor of change has some unique thing to contribute. I think that should go everywhere. That is the message.
Excellent, Dr. Rao. You gave some very good guidance to the mentors because that is true. You know, when you look at anything that is happening in our remote areas, the example of the charka you gave, the handicrafts that are being made in our hilly areas and tribal handicraft that is there, the work that is being done in our agricultural farms with very basic equipment, but they are able to still produce all the grains and be able to harvest them and so on. So there is so much to learn and there is so much to apply. And then the 3D printer comes in where even a small kirana store can operate with a 3D printer and start manufacturing toys or products or components which are needed by the industry. And so you have now made it possible for anybody with having a small shop or even operating from their own home and with a 3D printer and with their imagination and knowledge and access to the net and some tools, they are able to create products which they are able to sell. But more importantly, that product creation takes requires a skill which only that person has, that artisan has, the tribal handicraft person has. So how do you translate that skill into leveraging technology for furthering the product creation? That is the beauty of 3D printer, and it really enables everyone in an affordable manner to be able to think about creating products which otherwise they would have been very difficult for them. For example, an artisan will have to train 10 other artisans to do it. But now with a 3D printer, he is able to translate his craft and art into a 3D design, and then that is manufacturing by the hundreds. And so you are still able to retain the skills of the artisans and capture it in our through technology. So great concept. I would like to invite some questions from, I think Ronak is already getting a whole lot of questions based on the interesting observation that you made. But before they start, um, we at Atal Tinkering Labs have multiple technologies. You have 3D printers, you have IoT, which is Internet of Things, you have augmented virtual reality. Can you give an example of how 3D printing, IoT, and some other technologies work together to create a product? I'm sure there are many examples, but you would have in Imaginarium come up with products which get integrated with other technologies so that the impact of that product or the functionality of the product is enhanced. So can you give some ideas so that the students see how to leverage all of them together?
Wonderful. Yeah, it's a lot of projects, and company like Imaginarium, we are not supposed to talk about our projects. You know what we make for the companies.
Yeah.
You know, we. I think what are
Yeah.
there in public domain, we can always say.
Yeah.
We did a project for one company called Pyro Alpha. You know, and Pyro Alpha came out with a IoT device, and they had made it. The IoT device basically is a set of for layman it is like a set of electronics. It is there, and you put it somewhere in the building that tells you what is the temperature, what is the sound, what is the noise level, if there is any bad odor there. It is like a kind of a human being there who measures temperature, humidity, noise level, and any if there is any bad smell. And that transmits a long distance, and somewhere it gets logged. So based on which one can actually take control of that place. Supposing there is no noise, that means you can think there is no people there. You know, and if there is no light there, so there is no light and there is no people, and there is no noise means if there is a light, you can say, okay, there is a logic you can take. So there is no one there, light is on, so you can off it. So a set of logic, no, it can trigger. This is the IoT device. Now they had put it in a wooden box. Just imagine, it was put in a wooden box.
Yeah.
You know, and sometimes they require EMI, EMF shield also. Wood is not a good EMI, EMF shield also.
Right.
So the team was looking at the startup Pyro Alpha. My good friend, who approached us. We had to design the entire enclosure, and that was done using 3D printing.
Oh.
And 3D printing not only gave them, empowered them, in fact, to get funding. They expanded from one version to sixth or seventh version today, you know,
Excellent.
and they're deploying all over. It is going to control the HVAC, building smart, monitoring systems. So it's a great IoT device, which, like any other, it doesn't require a human intervention. It works, silently, and always right. There's no mistake. It works 24 hours.
Okay.
Capability. Then we had another project, for example, that is also now it has come out in market. It is a wristband which goes on children. It's
Yeah.
called Bempo. One of my designer friends, Mona Sharma, designed it, and the team, of Bempo, and they approached us. We want to make this, few numbers. We want to make it beautiful. We want to make it colorful,
Hmm.
but it is going on an friendly material. you know so we had to synthesize a new material for that, and without that this product would not have seen the light of the day. And when this was given to them, they were very happy. Then more designs followed. Even today we are in constant engagement with them, and we are very happy that this product is not only meeting the customer satisfaction, but ultimate customer is that infant. So this watch, what it does, it's very interesting to listen. It is about hypothermia.
Ah.
When the baby goes below some temperature,
Hmm.
dangerous levels, the baby, many times they die
Hmm.
in remote corners of the country.
Hmm.
So this is a hypothermia beep. So when the temperature goes down, the watch what they're wearing gives out a sound. You
Hmm.
know, and so mother is alerted. Many times these people, their parents work nearby.
Yeah.
It is like a building construction area and all. So this infant having a band is intelligent. When the temperatures goes down, it beeps.
Okay.
And that's how they're able to take the baby onto them, and comfort it,
Give them the
and
warmth.
they're able to save.
Yeah.
Yeah, and so it is now today. I think it is funded heavily, and they're coming out with various other products also. We are so happy that we could, help them out. Yeah, and such daily, a lot of such things could happen. In fact, during COVID time, we came out with a lot of options, including the face shield what we made. Then today, I think we have made more than 6 lakhs pieces. We have given to the local, police, the doctors, the healthcare people, NGOs, and I think we are getting very good, feedback from them. So we are happy. Technology is there for what? It has to change lives. It has to improve quality of life. You know.
So, one question I have, you gave an example of a great functional product which is leveraging 3D technology, which is leveraging sensor technology, and which is saving children, from hypothermia. And it's a beautiful example, simple device. So one can think of many such things. For example, when children go to school and you want to track, their movement, or they have entered the bus or whatever, you can have sensor technology. As soon as you enter the bus, you come to know, and then they are just wearing a band on their hand, and so that sensor technology or an RFID technology alerts the parent that yes, my child has caught the bus and is on the way home. And if they have not caught the bus, then they'll come to know. So there are many applications of this, especially in cities where it is so important for safety and people are concerned when young children catch a school bus or they have missed the school bus and so on. So there are many examples. Uh,
True, true.
I want your before I go to the questions from all the others. Uh, there is a there is a gap from a prototype to a product. You come up with a 3D prototype, so people think, oh, I innovated, but it is not a product. So, what is this journey between a prototype and a product? What is it that the innovator should look for to make sure that his or her prototype gets converted into a product?
Very important question. I think is a study model, a study model wherein you are going to work on it. So it is an externalized idea, and then it take form of. But unless we make it worthy of large scale production, a prototype, you know, aspects like design, uh, and and so so desirability of the product, you need to have the viability of the product, and you need to have the feasibility of the product. These are the three, a trinity that actually make a product a product. A product, if you make it, then that is not good. So you're making an error there, and error is important. Viability is to driven by various the functionality, and people have well, have a hand cast like this, it has to match to the hand. If it's not matching properly, then you're not doing job ergonomic. At the end of the day, it should look, it should not scare. It should look good. So it is important to your viability. Something like if I am going to price it something very high, it is good, but I think there's a problem. So I think startups need to look for a proper need. That is very important. After having established proper need, they have to design, they have to get it tested by not themselves. They have to test it with the users in an immersive environment. Many times people think I am solving a problem. You are trying to solve whose problem? Is very important. Your concept of a product can be totally different from the user, what he wants. User probably may want small little thing.
Excellent.
So I think the whole thing is about the viability, desirability, and feasibility. They need to really look after making a prototype. If it is not there, they have to go back to the prototype or drawing board. And so design is an iterative function. Yeah.
Excellent. So I think that's wonderful. The journey of an innovator begins with an idea, and then that idea gets converted through great design into a prototype, and from prototype to a product. The journey of an entrepreneur begins, where he or she looks at the feasibility of the product, the place in the market, the customers who are going to be buying and using that product, and then a business plan and a strategy to be able to manufacture to scale. And the quality of the product becomes very important, because unless it's a high quality product, nobody is going to buy. And so the journey of an entrepreneur begins when you start looking at how do I convert my prototype into a marketable, commercially deployable product. So wonderful. With that, Ronak, do we have questions from which students have asked, which you'd like to share with Dr. Rao?
Indeed, sir. I think by far we have received the maximum amount of questions from the students. Obviously, because it's 3D printing and it's so exciting. So pretty interesting questions from many of the students. One of the students is Latika, and she has asked a really interesting question. At these times of social distancing and safety norms, the students are actually a little away from the ATLs and have limited access to the ATLs. So can she create a 3D printer by herself in her own house? Can she actually make a 3D printer? That's what her question is.
Wonderful. I think it is possible, thanks to many kits available today in the market. And I think we should do it. We can help you. Imaginarium can help you. We have a lot of engineers, who are tinkerers and makers, and all of us are little bit tinkering always with the artifacts, and we can definitely teach you how to do it. And one thing you should understand, anything you want to assemble first, it will never work. And when it's not working, that's where our learning starts. And you will say, I've done exactly what you have told me, that it is not working. And that's where the actual learning of the principles start. It'll be a wonderful journey. We can help you. Over to you.
Sure, sir. Thank you so much.
I think that is a great thing. It's a great idea and a great question. And if we are able to enable our children, maybe one tinker from home module is how do you create your own 3D printer? And something like that, Imaginarium will be also able to help us. That will be a
Yeah, sure.
great online training module, and then people can experiment and create their own 3D printers.
Absolutely. Yes.
So in the paucity of time, we will take two more questions.
Sure.
The second question is from a team actually, and they are asking that how can we actually what are the best tools from where they can start the 3D design, and what does slicing mean? And they have also asked one more question. They actually observed you showcasing a small 3D printer. If you can just quickly share whether how does that 3D printer work, and how where's the nozzle and where's the bed print bed, that would be great as well.
Wonderful, wonderful. So the first thing about the product, how it is sliced. So I showed something like this, cylinder. It is a cylinder, is a part, and this cylinder is put on a 3D printer, one slice at a time. This is one slice. One slice is put on, it is written or printed, and over it again you are going to print one more layer. So in a way, 3D printer is a 2D printer wherein you print over and over again, so that you build thickness. So in order to make that, the digital model has to be sliced. Okay, after slicing, you put back at every time in a sequence the whole layers you are going to put back. And when you put it back, what you get is the integration of all the layers. And that's where typically why we want to print, and why it's called still as printer, is because it actually has a 2D, which is done again and again, over and over again. Over the layers, you're going to deposit 2D layers, and that's how you get the volume, and you build the beautiful artifacts what you see. Now coming to a 3D printer, you can see this is a 3D printer, a small little fellow. And you see here, I am not sure, there is a power failure here, so not very clear. What you see here is a print head. So you see a tube over here, a tubing. The tubing carries the filament. The filament is down below here. Here there is a platform. Below this there is a spool. That spool takes the wire which goes on the top, and it gets melted. In what you see here is a XY table. You know, this is X and Y, and what you have Z is this height Z. So XYZ is achieved by having to build the 3D models, and you can see here this head moves to and fro. So let me see. You can see here it moves to and fro. It can move to and fro, and it makes at any given time one layer. Then the head goes up, because there is a pillar over here, which is going to slide the by a discrete amount. And as you go printing layer by layer, you get the entire artifact done. So this is a very small printer, but if you want to build larger things, you go for a larger printers. In fact, in India, they built a very big printer in Udaipur, Jaipur. It traveled all over, and I think power has come, so you can see me better. Here now you can see some of these components. So this is the head, what you see here, and this is the table. You can see the table, and in fact you can see the spool also. I'll see if I can show you the spool. No, it is locked. I cannot show you the spool, but I think you can see the table. So larger objects are printed on a large. Of course, as and when you make complex things, you can do complex things like this. So this is a color printer based thing. This is made for children's correction of paucity, a defect, the congenital defect, which is corrected by using this. And also we can create very vivid colored, this is a heart model, for example, with all color, for studies and exploration and for surgical planning. And likewise, you can do many things which are very interesting. In fact, we can even make the impossible product like this. And you may believe, this requires a support, and this support was a powder, you know, and powder support can be easily shaked off or sandblasted, and you can have this impossible object. In fact, within this, you have a ball which is running inside. You cannot see, this ball is rotating inside, and that is possible only by uh, powder input. With filament, it is very difficult to make, and the filament have their own limitations. But this is a truly impossible object. Such objects can be done by additive manufacturing, and you can build a 3D printer of any complexity if you know. And every time when you build, something may not work. That is the first thing. So since I have been tinkering for a long time now, maybe more than 40 years or 45 years, making a lot of things like telescope or ham radio, building our own radio, building our own many stuff like that. you know Today we know, anything you assemble, it doesn't work in the first go. So you should never get disordered. But you come to the community, that's where the beauty is. When you come to the community and post your problems, somebody is there to answer you. And that is the beauty of 3D maker movement. I think it's going to help everyone to face the world, not get frightened about the world, to face the world and offer solutions. Don't sit back and think why but you instead proactively contribute. So in COVID time also, people have been doing a lot of things because of the intent of the society is increasing, and thanks to Atal mission, innovation mission, I think within a matter of 5 years or so, when all of you become the creators, I think India is going to have a wonderful future, because it is going to be your India, where you have created many things which are for you, by you, and to all of us. Okay, thank you.
Thank you. Thank you so much. As all the participants may be aware, or we'll let you know, Imaginarium has agreed to collaborate with Atal Innovation Mission in launching a 6-week webinar series on 3D technology. And we are very, very proud and privileged to have Imaginarium as a partner in the dissemination of this very vital information about a technology that is exciting the entire world. 3D printing is an area of great promise because it takes away from what was conventionally possible only in large manufacturing locations with a lot of costly equipment to be implemented and installed for you to be able to manufacture products. But today, you can actually conceptualize, design, develop, and print, 3D print. And that is literally manufactured in your own home. As one of the students asked, can we create a 3D printer ourselves? And that is, you can 3D print a 3D printer. Now that is the beauty of this particular technology. And therefore, the promise of this technology, the chance, the opportunities with this technology, and when you integrate this with the other emerging technologies like sensor technologies and so on, really open up what is known as IR 4.0, Industry Revolution 4.0. And that is the revolution that is out there in the world. And every one of you young Atal Tinkering Lab student who is onto this call, you have an opportunity to become an IR 4.0 innovator. And that's what you should be looking at. And we are very, very happy that Dr. Rao has shared his knowledge, his experience, his insights, his advice, and his guidance to not only the students, but also the mentors on how you can leverage technology for the benefit of the society and for common good. And at the same time, leverage it for economic progress. I do want to thank all of you for joining in this call. We are, like I said, going to be launching the 6-week webinar sessions and series on 3D printing and 3D technology. So please tune in, look forward to the sessions, and I am sure every one of you will have an outstanding 3D printing design. And I hope your offer still holds, that if somebody gives 365 good ideas, you will be giving them a 3D printer. So if that idea, if that still holds, I'm sure all the students out there who are listening, it will be wonderful to receive your ideas. Whether you get a 3D printer or not, you would have become a 3D fan by then. So it's great thought, and I really encourage everyone. So with that, Ronak, anything else that you would like to add to this particular session?
Thank you so much, sir. I think we can conclude, and with your permission, and we can also have Mr. Guruprasad to share a few words as an exit or closing to this session.
Yeah, Dr. Rao.
Thank you, Ronak. Thank you, Mr. Ramanan, for a very wonderful opportunity to reach out to all my children, students, the faculty, mentor of change, and my fellow experts on the other side, to reach out. I always say it is a learning together session. And in the whole, we also learn every time, and I think we will make this mission a great success together and contribute to this. It was my pleasure to share our knowledge, and we look forward to offer this 6-week or 8 weeks program, wherein we are going to introduce every concept which can be understood so well, and it is going to have a rich with a lot of activity, and people have to do some homework and submit them in order to have the next it becomes a prerequisite kind of thing. Not so, but I think it is good if they do activity, and at the end of the 6 or 8 weeks, we are going to really have something which will be very, very interesting to see for all of us. Thank you so much.
Thank you, Dr. Rao. And we are very excited to launch this webinar series along with you. And like you said, at the end of it, we will also recognize your completion, successful completion of that through a certificate that will jointly create between Imaginarium and Atal Innovation Mission, which you can have. And of course, your innovation is the greatest reward. More than anything else, your learning and your innovation is going to be the greatest reward that you're going to get. So we are very excited. All of you who have been on this call, thank you so much for attending this call, participating in it, asking your questions. Many of the questions that I asked were based upon a list of questions that Ronak had already collected from you. So I'm sure this is a representation of most of the questions that were asked by you. Please keep tinkering, keep innovating, be safe, and become a part of the innovation world that we all live in. Thank you so much. Have a great evening and very happy weekend to all of you.
Thank you.